Hey kids, so today what we're going to be looking at is a function notation. And yesterday we saw what functions are. Now we're going to analyze that a little bit more. So imagine we had an equation, which we've seen many times before, y equals mx plus b. That's the equation of a line. It's also an example of a function. The function can be used, this can also be written using function notation. So the y just changes to f at x. So we say this as f at x, okay, f at x. Or some teachers and some people will say f of x. Both are technically correct. So x in the bracket tells us what variable we will see in the function itself. If we have f at g, then we will see the variable g in the equation, okay? So since we had the variable x, we need to use x inside our brackets. That's simple. All right, so we can read it as f of x equals 3x plus 4, or f at x equals 3x plus 4. So a common question with equations is this. If y equals 3x plus 4, find y when x is 7. What function notation allows us to do is say this in short form. So what we say is find f at 7. And so what this means, it means x equals 7, find the value. So what you're going to do is find f at 7. And so instead of 3x plus 4, f at 7 becomes 3 times 7 plus 4. So we're going to take the 7 and substitute in for the x. That's all the function notation is saying. So stuff that we've done just looks a little bit different. So what we're going to do now is practice this with some harder situations. So here we have two functions, g of x and h of x. So what we're saying here is find h at 2. So we're going to take the 2, substitute into our equation right for the x value. Instead of 4 times x, it's going to become 4 times 2 plus 4. So we can show our work just below, and we can say h at 2 equals 4 times 2 plus 4, 8 plus 4, and so our answer is 12, okay? G at 3, so now we're going to take 3, substitute into our g function, and so we're going to find g at 3. So that equals, instead of x squared, 3 squared minus 1. And so g at 3 equals 9 minus 1. Our answer is 8. Now we have h at negative 5, so we substitute in the value. Always when you substitute, use brackets, use brackets, use brackets, use brackets, use brackets, use brackets, use brackets. We use brackets so we don't write 4 minus 5 plus 4. Okay, that's why it's important to use brackets, because that's wrong. It's actually 4 times negative 5 plus 4. So we would get negative 20 plus 4, and our answer is negative 16. Okay, so those are the easy ones. Now for some more tricky ones, what if we have a letter r? Well, it's quite simple. G at r now equals r squared minus 1. So where we have x, it becomes r. What about x plus 2? That's a little trickier. So now we're going to have to do some algebra. So instead of x squared minus 1, we're going to get x plus 2 all squared minus 1. Now remember, I'll do that on the side. That will become x plus 2 times x plus 2. Which equals, remember this, here we go, multiply and multiply, x squared plus 2x, and our next multiplication is plus 2 times x, so plus 2x, and multiply again, plus 4. A lot of you thought there was a shortcut, and you thought it was like a difference of squares or something like that. So what we can do now is replace x plus 2 squared with no brackets, x squared plus 4x plus 4. And don't forget, we have this minus 1 part. Okay, and so that's the value for g of x plus 2. So we can now have to combine those, and so our final answer will be x squared plus 4x plus 3. Done. Okay, so just to remind you, this work is right here. There you go. H at g at 3. So what you have to do is you have to find this first. Okay? So find the value of g at 3 first. Lucky for us, we did that. Haha, for those paying attention, g at 3 equals 8. So really what this is saying then, find h at 8. Okay? And so we take this value 8, we substitute it in here. And so this equals 4 times 8, using brackets of course, plus 4. 4 times 8 is 32 plus 4, so the answer is 36. Okay, so here's some other weird ones. H at 3, pretty simple. 4x plus 4, so that becomes 4 times 3 plus 4. 12 plus 4, answer is 16. Okay, just write a few things down. Don't be so lazy. Understand the process of substituting. All right. So next one, we have 3 at h of x. So we still have a 3, but it's in a different location. That means it's different. It's not the same. So 3 at h of x means it's 3 times, big brackets, h of x, big brackets. So you've done this before. We just did a lot of this unit. So it's 3, basically, this equals 3 times 4x plus 4. And so we have to use our distribution rule, multiplying properly. So 12x plus 12. Okay? Good. Now we have something completely different. Now we're saying that, this is like saying y equals 3. And so what you have to do is you have to find x. You have to work backwards. And you've done lots of this before. So we have 4x plus 4, and we have 8. That's what h of x is. So now this value replaces h of x. So 3 equals 4x plus 4. And so now we're solving for x. So minus 4 both sides. Minus 4, negative 1 equals 4x. And so then we divide by 4. And so we get x equals negative 1/4. And that's your x value. Done. Okay, so it looks different. It is different. You got to work backwards on that one. Next one here, find g of x equals 35. So we have x squared minus 1. So g of x equals x squared minus 1. We substitute this value in for g of x. So we get 35 equals x squared minus 1. X squared equals 36. All I'm doing is moving this to the other side, solving for x. And so then what we have x equals square root 36. Now, that's not bad, but it's not a good answer. The real answer is x equals plus or minus the square root of 36, because x could equal positive 6 or negative 6. So we have to write plus or minus. That's something new for us. Haven't seen that, but negative 6 is a very valid answer. Okay, moving on. This is just a fancy way of saying, this is a fancy way of giving a point value of negative 1 for your x and negative 7 for your y. Here's a fancy way of saying 5 for your x, 9 for your y. So you have 2 points. You could start finding your slope, and then you can put it into slope point form. okay? But we're not going to do that. You can cross that one off. That's a little more than I feel we should go through, okay? So what about from a graph? Well, we can read our graph as well. So what we're saying here, x equals -4. What does your y equal when x is -4? So at -4, here is -4. What is the graph value? Well, right there on our line, our y equals 6, 7, 8. Okay, so we can say the answer is 8. So f at -4 equals 8. So our x value is -4, our y value is 8. At f at 0, so x equals 0. And so right here, here's 0, x equals 0. And on our line, we are at +2. So our answer is +2. Good. X equals 4. So 4 on the positive. Here's 4 on the positive. And on our line right here, we are at -4. Okay. Now we're working backwards for this one. So now we are saying y equals 4. So at y equals 4, here's our line. Well, guess what? Our line is touching here, here, and here. We have 3 possible answers for our x value. Our x value is -4, -1, and +8. So here is -6, my bad. -6, -1, which is right here, and +8, which is right there. More graphing. Okay, does this graph represent a function? Well, vertical line test seems to be passing, and you're thinking, well, what about right here? Those 2 points overlap. Well, remember with an open circle, it's not actually here. And so it's actually here. So we will say, yes, it's a function because it passes the vertical line test. Passes the VLT, vertical line test. And yes, you'll be using that in grade 11. Okay? Now, what about when x equals 9? Well, for f at -9, when x equals -9, that's right here. And my y value is what? -2. What about f at 5? Well, right here, this point, my y value is 7. What f at 1? Well, right here, I have to go down to the bottom point. Okay, so I actually have this point. Here's f at 1. My y value is -2. And what's f at 4? Well, f at 4, so now this is saying y equals 4. I'm going backwards. So here's 4. I go over to my line, and then my x value is +2. Okay, done.